I need to find the ionization constant, Ka, for HCN given the concentration and degree of dissociation. *** given information, *** initial concentration, C equals 0.1 m degree of dissociation, alpha equals 0.01% equals 0.0001 *** Step 1. Find the concentration of H to the power plus ions at equilibrium *** H to the power plus equals C times alpha equals 0.1 times 0.0001 equals 10 to the power minus 5 m ***. Step 2. Set up the dissociation equilibrium *** HCN right lefter poons H to the power plus Cn to the power at equilibrium H to the power plus equals 10 to the power minus 5 m Cn to the power equals 10 to the power minus 5 m. From stoichiometry, HCN equals 0.1 10 to the power minus 5 approx 0.1 m. Since alpha is very small. Step 3. Calculate Ka Ka equals H to the power plus Cn to the power over HCN equals 10 to the power minus 5, 10 to the power minus 5 over 0.1 Ka equals 10 to the power minus 10 over 10 to the power minus 1 equals 10 to the power minus 10 times 10 to the power 1 equals 10 to the power minus 9 m ***. Answer Ka equals 10 to the power minus 9 m or 1 times 10 to the power minus 9 m. This matches option *** D *** and is consistent with the known Ka value for HCN, a weak acid. The answer is D.